Hello, y'all. Welcome to the Spot Robotics Podcast. Today I'm joined with my guest, Mr. Miguel Martinho, and we discuss AI and machine learning and how they relate to space travel. I hope you enjoy this podcast where you can gain insights into developments of technology in the modern world and gain a new perspective on how to succeed in these fields. If you enjoy this podcast, make sure to follow us on wherever you get your podcasts, and if you'd like to support us even more, make sure to check out our Patreon. Thank you and enjoy. Okay, so before we begin, could you please explain what you do and what your job is, and for what industry / organization do you work for, and a little brief explanation of your background? If you don't mind.
Mm-hmm. Yeah, sure. So I'm Miguel Martinho, and I work for NASA Ames Research Center. Um, Now, inside NASA Ames Research Center, I work specifically in the data sciences group, and this was a group uh, that was designed with the mission of developing machine learning based solutions to problems in the area of that align with the NASA mission, and those projects can be in terms of earth sciences, aeronautics, and space. More concretely, in my case, I've been working more in projects related with space. One of them was in the area of space biology, uh, more related with astronaut health. It dealt with basically helping with the segmentation of blood vessels in the human retina. Now, there's a lot of interest in understanding how the morphology of blood vessels change in environments of microgravity and higher radiation that we see here on Earth. And those kind of environments, you can find them in the ISS when astronauts are there for, 6 months or even several missions in the ISS, or even for deep space exploration, which will be the case in the future when exploring the moon and even Mars. And we know already, even from just the ISS missions, that there's definitely damages happening to the morphology of the blood vessels. And in this case, people were interested in understanding what changes in terms of the blood vessels in the human retina, just because it's easier to actually acquire images, right? You don't need to do any invasive process. You just need to take photos of the retina using a mechanism such as angiography. And so to speed up the process in terms of understanding what kind of therapeutics they can develop to make to counter the effects of microgravity and radiation, we were tasked with developing a deep learning model. In our case, we decided to go with a convolution based model neural network to perform the segmentation of the blood vessels. So meaning which pixels are belong to the vessels and which pixels belong to the background, and then then the researchers can use those images to understand how, in terms of different metrics, how the diameter and maybe the tortuosity of the vessels change. They've seen that in those cases there's a process of neovascularization, meaning that new blood vessels, especially capillaries, the smallest vessels, they are formed, but they are fragile. That can lead to, hemorrhages, and then eventually we want to understand how can we treat those processes, or how can we even counter them. One of the other projects, and that's the project that I've been part of for the longest time that I've been with NASA since 2019. It's been using machine learning models to help in the vetting of transit signals from missions such as the Kepler and the ongoing test mission. So these missions are NASA missions. Uh, the test is led by MIT, and they are space telescopes, survey missions, whose ultimate goal, or main goal at least, is to find exoplanets. So to have a better understanding of the population of exoplanets that we have in our galaxy, understanding the mechanisms by which different star systems form. How rare is Earth in terms of rocky, habitable planets, or at least a first step. And now with the whole JWST, the James Webb Space Telescope, now we're going into a field of understanding, characterizing the atmospheres of these exoplanets, so planets outside of the solar system, and trying to get closer to actually understanding whether they can be habitable or not. But my focus was essentially being part of a team to develop machine learning algorithms to basically sift through the huge amounts of data from Kepler and now TESS, and basically guide astrophysicists, guide the exoplanet community towards more interesting transit signals, because so basically just to give an idea, that there are several methods that people have developed to detect exoplanets. So the first exoplanet was detected actually in the 90s, and the most popular method to detect exoplanets is called the transit method. So that's the one that has been used by Kepler and now also by TESS. And so basically, if you think, for example, from our perspective or from the perspective of a telescope orbiting the Earth or the Sun and pointing to some part of our galaxy, let's say that the telescope is focused on a patch of the sky, right? And that sky obviously contains millions of stars. And let's say that there's a few stars that people already selected as potentially interesting stars to be observed because they are bright. They have the characteristics that we think they could harbor planets. So they focus on one of those stars, and then they watch. The space telescope captures the light that comes from that star for a period of time. Let's say in the case of Kepler, it was many years. And so imagine that they would have also a kind of an Earth around them. So from our perspective, this kind of Earth, right? It would orbit, pass in front of the star every 365 days, and so you would see a slight decrease in the brightness of the star because you'd have this small planet orbiting in front of the star, so transiting, hence the name. And so what the signature that we are looking after is this kind of small dip, periodic dip. In the case of this Earth would be 365 days, but obviously there's many planets with different orbital periods. The first planets that people started finding were what they call the hot Jupiters, so planets that orbit really close to their star. Think about doing a whole period in 5 days, and they are really big, so their signal is really clear. And so there's a lot of these kind of stars, and what we did with our algorithms was trying to basically develop an algorithm that would provide a score, a confidence on how likely that star can have one or more planets associated with it. So that's what I've been mostly working on. In terms of my background, well, that's interesting you asked, because so I did my master's. In this case, it was an integrated master's in biomedical engineering, meaning that both my bachelor and my master's were in biomedical engineering, which is, I know it's a different field than the current machine learning / astrophysics. But towards the end, towards my master's, I started delving into kind of machine learning, AI, and that's where I started, with the traditional machine learning methods, and then eventually getting acquainted with deep learning. And then eventually I ended up doing an internship at NASA Ames Research Center, which then ended up turning into a full-time job after that internship. But if you want me to go into more detail, I can go.
That was really interesting, like stuff, like the work you did. I just want to ask, you said at the end of your master's degree you started getting into artificial intelligence. Could you talk about what inspired you to start pursuing into the artificial intelligence career, and why you got started into it?
Mm-hmm. Yeah, sure. So in the case of my university, when you go into your master's in biomedical engineering, you can specialize in different fields, be it biomechanics, stem cells, even hospital kind of management. And then the branch that I ended up specializing was the medical imaging electronics and signal processing. And signal processing involved a bit of exploring different methods for process biosignals like electrocardiogram, um, or electromyogram. So the electric signal from your muscles, or in this case from your heart, the ECG, or even EEG from your brain. And then I remember we had a project which was with this kind of robotic arm, and we had some some uh, some electrodes attached to our skin, in our forearm, and we wanted basically to map certain muscle activations to specific degrees of freedom of this robotic arm. Now the robotic arm didn't have as many degrees of freedom as our our arm. That would be quite a quite a project, and we still are not there, I think. But basically, think about like that arm could twist, could it had a claw that could like close and open, and so in order to do that kind of mapping, you can resort to some kind of, I guess, thresholding techniques, kind of in terms of if this electrode goes past this certain level of activation, electric activation of your muscle, of this group of muscles, then do that, right? You can have that kind of if-then rules. But then we started exploring, in this case, neural networks to do that kind of process, and it was really fun, and we could actually control. It was not the best mapping, I'll give you that, but it was fun, and so that kind of made me more curious about machine learning, and then I chose to have a proper machine learning course during my first year of my master's, and then also another one in AI. When I say AI in this case was more, think about more like traditional AI from the 60s, 70s, where it's not like machine learning based, it's more this kind of search algorithms, like A star and stuff like breadth first search, and stuff like that, and actually also involving even a bit of control. So yeah, that was kind of my path into machine learning / AI. And then I also, obviously, for deep learning, I didn't take any actual course during my master's. Deep learning at that time was kind of starting. It was popular, but I guess not popular enough to become an actual part of the program of my machine learning course, or even like its own course, at least at my university. So then I just learned by myself, using resources online, like I think even Stanford had some courses, had the lectures available online, and you had like Coursera with Andrew Ang, and
Pretty
yeah,
cool.
that was mostly
I just had a side question when you were talking about deep learning model for like blood vessels. Do you think the work you guys
Mhm.
did, do you think that could be applied in further like sense to the missions to like Mars or missions to the moon? Do you think that would be something that your like work would be applied to?
Um, I think this kind of work that we did, and I think now looking back, so I'm not working on that project anymore, and I think of a few things that we could definitely improve on it. But looking back, I think that work is more like an offline thing, in the sense that um, I can think of a setting where, let's say that we move on to uh, analyzing. So imagine like astronauts on the, I don't know, on the lunar gateway, or actually on the moon, and you want to you want to every, like daily or maybe weekly, maybe take pictures, samples from them, in terms of, for example, images of their retina, and see how it's changing. And then if you have a model like that, you could then provide the segmentation. That segmentation would be sent to another software that computes all the kind of metrics that you might want to extract from uh, the human retina, and that can give you an idea of how the morphology is changing. But for the kind of project that we were working on was more like how can we, or the research were interested in how can we basically counter the effects, and they were studying different drugs, and also even kind of funny, like they saw, even I'm not sure exactly how they tried it, why they tried this, but they saw that plums, for some reason eating plums would kind of retard the effects that they were seeing in some subjects. I'm not sure exactly why, that's not my field, but so it was more like, let's try to design therapeutics to counter these effects. Once we establish that they actually work, then astronauts and can follow these procedures, and I guess you can monitor them while they are outside in deep space, and actually see if it's working. But yeah, that's what I think it could. I think it's more focused on something more offline, so not in real time there. But I guess if you have some kind of labs on the moon, and this is me speculating a lot, I don't know. Maybe it could be integrated in some
So
way.
basically,
Yeah.
you guys just researched on how the retina would change, and you guys would like find the patterns, but you guys wouldn't solve the problems. That was another team, right?
Yeah, so they had a bottleneck, which was they need the segmentation maps. They need, basically, you have an image of the retina, right? And you want to know which part of this image, which pixels are actual blood vessels, right? So you can either have a person doing that manually, which is kind of boring and time consuming, or you can have some algorithm, right? Automated method. So that's what we worked on. We didn't work on finding, the pathways or the actual um, um, solution to this specific challenge. It was more, you know, making the process faster for the researchers on that field, related with like astronaut health, space biology, to understand what kind of drugs or what kind of procedures they can use to counter the effects of microgravity
Okay.
and
While we're
radiation
on the topic, I
in
want
deep
to ask:
space.
did you face any challenges while either in the Kepler and the tests, like part of your job, or the blood vessel analysis of your job? Like, do you face any challenges, like any challenge, any data challenges, or any
Mm-hmm.
physical constraints of any sort?
Uh-huh. In terms of yeah, so I think there's several challenges. One of them, I think it's how people, you might sometimes be lucky and you might be unlucky in terms of how people see your work as a kind of machine learning researcher, or more like data scientist, and how skeptics they are from of these technologies. Some people are really, even if they are not from the field, they are really enthusiastic. Other people are not, and I guess you need to convince them and fight a little bit to get some ground. But I mean, I guess that takes some patience and just understanding exactly what they're looking for, and because they are not coming I mean, this is not your field,
Yeah.
probably, right? And your field is also not their field, so how do you communicate between those two fields, and also manage expectations, right? I mean, people think like, oh, it's machine learning, it's going to solve everything, and there's no problem, and I can give you low quality data and and expect magic.
Yeah.
I mean, that doesn't happen. The other one is so let's say, like, okay, we developed that CNN, that convolutional neural network method, and now we want to deploy it so actually people can use it on their own laptops or computers, right? But then you're thinking, oh, wait a minute, do their computers even have GPUs to run it faster? I mean, it's inference, so it's gonna be faster either way. They're not training the models themselves, but you still need to think about that. If they don't have access to GPUs, then things can become slightly slower, and maybe you need to go with a smaller model, or they're just gonna. I mean, they need to. So you need to communicate that what is the expected speed that they're gonna get. And I think I had other thing.
Okay.
Let me think.
Well, I just want to ask. I want to shift away from more of the work and ask some advice. I just want to ask, since you've been through so many challenges and you've experienced a bunch of the machine learning like space and deep learning space, would you have any advice for anyone trying to
Mhm.
pursue a career like yours, like in artificial intelligence and machine learning? It could be any industry, but just in particular, like in machine learning, artificial intelligence.
Um, well, um, I think advices. Um, I think one piece of advice I would give is that I think it's crucial to keep up with the field as much as you can and be curious and open to new ideas and new things that are. I mean, I know that there's a lot of things, and you
Mm-hmm.
only have 24 hours in a day, and you need to sleep and do other things and have free time. But try to read and learn more about what people are doing in the field, and yeah, if you have a chance to go to conferences, definitely that's a good way. Like associate yourself with some research group, um, and then if you can go to conferences and just interact with people in areas that you might find interesting, I think that's for sure the best way. Um, and so far, I think at least when I interact with people, they are kind of they want to tell you things, and they tend to be um, nice. But yeah, that's mostly it.
Okay. I just wanted to ask, um, what do you see any emerging trends in artificial intelligence and machine learning? It could be related to your field, it could not, that are very promising for future exploration or like future human growth. Like any fields that like really stick out to you
Mm-hmm.
right now?
Oh, besides the
Yeah.
kind of obvious the answer, which would be the kind of generative
Mm-hmm.
large language models that even NASA is considering in some applications. And I guess a lot of companies are just considering the same thing. How can we leverage these huge models to our specific um, problems, and so that's obviously something that NASA is looking into. I don't know any details. I'm not involved in any of this project, but I'm definitely know that there's some funding in
Mm-hmm.
that area for to explore those kind of models. Besides that, I don't know. I really like unsupervised learning models, especially like in terms of contrastive learning. I really think it's cool. Um, Whether it's gonna become really promising, um, and like a thing that is used in terms of unsupervised learning settings. Yeah, I'm not sure. I think there's more better people to answer those kind of
Mm-hmm.
more like fundamental AI questions. But I really like that area of contrastive learning. Um, yeah, right now I'm starting or trying to start a project in terms of uh, trying to clean James Webb Space Telescope data from cosmic ray hits, and there's not that much labeled data, so we're thinking about maybe using some sort of unsupervised learning um, to address that issue. I wonder if some contrastive learning approaches that I've read about um, could be a good approach to that challenge. But I don't know. I haven't tested, but I think that field is
Okay, I just
definitely
had
interesting.
one last question before we wrap this interview up. When you look back
Mm-hmm.
at your journey as like from where you became from like your machine learning like internship at NASA, do you see anything like if you need to look back, do you see anything and you say that I could have done better on that, like or something I could do improved? I know you touched based on that for like your deep learning for the blood vessels, but
Mm-hmm.
anything else in particular?
Oh, when I look back, I definitely should have. learn sooner about version control. That's a thing that it's just way easier to track the changes that you've done, and especially if you're working on a team that is not you but more people writing code. It can become chaotic if you just don't use version control and you don't learn how to use it properly. So that's definitely some like Git. Like yeah, that's something that you definitely, if you're writing code, even I would say even in academia, I think that's useful. You can even go back and see what you did and write comments and keep things clean. Um, and definitely log like your results and your rationale to do a thing, and so why did you decide to go with this approach? What were the results? Because sometimes you'll have to go back to your previous experiments and basically understand what was happening. Um, so I think those are the main things. I mean, I think these are both useful for a researcher, but also even if you just go to the industry. I mean, you'll be doing tasks, right? And you need to know exactly why you're doing it. And then if you want to go back in time, just to, and someone asks you, oh, why did you do this? And you're like, oh, I did it because A, B, and C. And you don't need to have it on top of your head, or at least not the details exactly. You can just go there. Um, so yeah, definitely version control and logging things. I know that there's even like uh, some platforms for data managing that I haven't explored much, but at least for code, definitely do version control, and then you can use tools like I don't know OneNote to log your experiments, keep track of what you've been doing.
I know
Stuff
I
like
said I
that.
had one last question, but if you have time, could you explain a little bit more what you did? Like you talked about like a internship you did at NASA, and when I was looking for looking for internships for the spring year for this year, one of the internships that came up was
Mm-hmm.
related to Kelper and test data sets. It was like a junior machine. So could you explain a little bit of what you did in your your internship at NASA? Because I found that really curious.
Yeah, yeah. So my internship was exactly in the field of the segmentation, image segmentation
Mm-hmm.
for the blood vessels in the human retina. So that's where I did my internship, uh, and then at the end of my internship, um, I eventually applied. There was actually an opening at my group, and I applied. And then after that, I continue working on that same project. Uh, and then after a few months, almost a year, I eventually switched to the exoplanet transitional classification project with Kepler and Tess. Yeah.
Well, if you do you have any questions for me or anything like that?
Um, no, so I guess the question or the main question I have was um, uh, what was your I guess your main goal with this kind of interview, and what are your
So
plans for the
really,
future?
my main goal was really to, the field of machine learning is so, and like data science is really like a really massive field, and I feel like, in school right now they don't, like in my school in particular, they don't teach it as much, so there's not much knowledge base and like advice around exactly like how you want to enter into AI and machine learning. And there is like the hype around, yes, machine
Mm-hmm.
learning and AI is the future, but like I feel like in the sense that the skills aren't taught for going into that career, they're just taught as a supplement. So I feel like the whole point of this interview was to, I guess, gain some knowledge, because I found artificial intelligence really extremely like interesting even before all this chat GPT and all that. I feel like it was like one of those things when I saw like those like the like the Boston robotics videos. I found that really cool. Robotics has always been something that interested me, and I said that
Mm-hmm.
AI has been those things I've been implementing into robotics. So I feel like that was one of the things. And then for the future, for this, like side projects, I just want to like keep like interviewing, talking to more like people like you in the field of like computer science and artificial intelligence, ask for their advice,
Mm-hmm.
because I feel like through that you have that practical sense. You can see what others have done, what mistakes they've made, and you can, I guess gain that knowledge base, and you can also like I guess see the cool stuff and like kind of like, I guess, make it digestible, see the cool stuff that is available, like what work people are doing. I feel like most of that work isn't really like, I guess not, is like unnoticed kind of, you could say, like, because they won't present it, like they won't present that much stuff about it, or they're trying to keep it very simple. But I feel like when you talk to someone who actually builds the stuff, that I feel like you get like a real like hands-on experience, and you can see exactly the steps and everything like that went on, like how you did it. Okay, well, I
Mm-hmm.
guess with that, I think we can wrap up the
Yeah.
interview. I want to thank you so much, Mr. Martino, for letting me interview you. It was a very, good experience. I feel like got to learn a lot about NASA, and I'll hopefully get to work with you in one of the internships maybe for the Kelper and
Mm-hmm.
test data. That's it for today's podcast. Again, if you enjoyed this episode, make sure to follow us on wherever you get your podcast. And if you'd like to support us even more, check out our Patreon. Until then, we look forward to seeing you in a future podcast very soon.